Welcome back to my class in Mathematics Self-Investment. For today, we will take up how to find the unknown time at compound interest rate. And for our first example, consider the following problem. 37,600 pesos accumulates to 41,123 pesos at 7 and 2 pips percent compounded monthly. Find the time t. At the end of the solution, when we finally find the value of t, we will write t in years. But before we proceed with the solution, we write the given information in the problem. The problem says 37,600 pesos accumulates to 41,123 pesos. That means that 41,123 pesos is the accumulated value denoted by capital A. So we write in the given information, capital A equals 41,123 pesos. That's the accumulated value of 37,600, which means that 37,600 is the original amount invested or the original amount borrowed, and it is called the principal, which is denoted by capital P. Hence, capital P equals 37,600 pesos, which accumulates to 41,123 pesos at the rate of 7 and 2 percent compounded monthly. Because the interest is computed more than once in a year, it's computed monthly in a year. The given interest rate is a compound interest rate denoted by small letter j. Thus, small j equals 7 and 2 pips percent. And when we substitute the interest rate in the formula, we should write the interest rate in decimal number. So we convert 7 and 2 pips percent to decimal number. You start with 2 over 5. You divide 2 by 5. You have 2 divided by 5. 2 divided by 5 is 0.4 plus 7. So 7 and 2 pips percent is equal to 7.4%. And that is still percent. So you divide 7.4 by 100 to convert it to decimal number. 7.4 divided by 100 is 0.04. 0.074. Again, to convert 7 and 2 pips percent to decimal number, you convert the fraction 2 pips to decimal number by dividing 2 by 5. You divide 2 by 5 and you get 0.4, and you add the whole number 7. 7 plus 0.4 is 7.4%. But that is still percent, so you divide that by 100% to convert to decimal. 7.4 divided by 100 is 0.074. And this is the compound interest rate in decimal number, which is compounded monthly. And that means that the value of m, the number of conversion periods in 1 year, denoted by small m, is 12. And we now find the interest rate per period, denoted per month. Our conversion period is equal to 1 month. And we find the interest rate per month or per period denoted by small I. The interest rate per period in this example per month is the annual interest rate J divided by the number of interest conversions in 1 year by M, or I is equal to J divided by M. And J is 0.04. sorry, 0.074 divided by M, 12. Okay, we will take this number as is and we will later divide 0.074 by 12. And we are asked to find the time t, that is the required. We write the required is t. And because this problem involves compound interest rate, we use the formula for accumulated value, at compound interest rate given by the following. At compound interest rate, the accumulated value is computed by this formula, A equals P times quantity 1 plus I to the power N, where I is the interest rate per period, which we have already computed, and is equal to 0.074 divided by 12. Or in general, the interest rate per period is equal to the compound interest rate J divided by the number of conversion periods in 1 year. And the exponent N is the total number of conversion periods or the total number of interest computations for T years. And N is given by M multiplied by T. The total number of interest computations in T years, for T years, is given by N, and N is equal to M multiplied by T, where M is the number of conversion periods in 1 year, or the number of interest computations in 1 year, and T is the number of years. And we substitute the number of conversion periods for this example. Because the interest rate is compounded monthly, the number of interest computations in 1 year is 12, and we multiply that by T. Thus, the exponent N is equal to 12 multiplied by T, and T is unknown. We now write the equation from which we can obtain T, the unknown time T, using the formula for accumulated value at compound interest rate. We substitute the given A, accumulated value is 41,123 pesos. And it's equal to P, the principal, the original amount borrowed, or the original amount invested. P is equal to 37,600. Multiplied by quantity 1 plus I. The interest rate per period I is equal to 0.074 divided by 12. And this sum 1 plus 0.074 divided by 12, that's 1 plus I, is raised to the power N, where N is equal to 12T. And this is the equation from which we will solve for the unknown time T in years. And the first step is, as in solving other equations, only the unknown variable should be at one side of the equation and all the constants should be at the other side of the equation. So we start one by one, we remove all the constants at this side of the equation, and we start by removing 37,600 by dividing both sides by 37,600. We divide the left-hand side by 37,600. And we also divide the right-hand side by 37,600. And 37,600 divided by 37,600 is 1. or we simply cancel out 37,600 from the right hand side. At the left hand side, we still have 41,123 divided by 37,600. At the right hand side, we have 1 plus 0.074 divided by 12. At the right hand side, we have 1 plus 0.074 divided by 12. 1 plus 0.074 divided by 12 to the power 12t. Because t is in the exponent of this sum, we should bring it down by taking the natural logarithm of both sides. We take the ln of the left hand side, we take the ln of the right hand side, and we use the property of natural logarithm to the right hand side. We apply one property of natural logarithm to the right hand side. That is the same process we did when we took finding the unknown compound interest rate in the last lesson. We now take the natural logarithm or ln of the left hand side. And we also take the ln of the right hand side, or the natural logarithm of quantity 1 plus 0.074 divided by 12 to the power 12t. And we apply the property of natural logarithm to the right hand side, which says that this is the property of natural logarithm that we will apply to the right hand side. The ln of x to the power n is equal to n times ln of x. That is, the exponent n of x is brought down as coefficient of ln of x. The exponent here, 12t, will be brought down as coefficient of ln. So applying this property of natural logarithm to the right hand side, we write the right hand side as 12t multiplied by ln of this sum. By this property of natural logarithm, the ln of x to the n equals n times ln of x. We brought down 12t as coefficient of ln. 12t multiplied by ln of quantity 1 plus 0.074 divided by 12. The left hand side is as is. From this equation, we can now have t, only the variable t at this side of the equation, if we divide both sides by 12, and if we divide both sides by ln of 1 plus 0.074 divided by 12. So we divide the right hand side by 12. Multiply by ln, we also divide this right hand side by ln of 1 plus 0.04 divided by 12. And we do the same to the left-hand side of the equation. We divide this side of the equation by 12. The product of 12 and ln of 1 plus 0.074 divided by 12. From the right-hand side, we can cancel 12 and 12 because 12 divided by 12 is 1. And we can also cancel ln of quantity 1 plus 0.074 divided by 12 because this quantity divided by the same quantity is 1. And what is left at the right-hand side is t. So t now is equal to this quantity divided by this quantity. So the time t we are looking for is equal to ln of 41,123 pesos divided by 37,600 pesos divided by 12 multiplied by, divide by 12 multiplied by ln. Divide by 12 multiplied by ln of quantity 1 plus 0.074 divided by 12. If you have scientific calculator, you can compute this directly in your calculator. Or if it is convenient for you, you start with computing the ln of 41,123 over 37,600. But you take all the decimal numbers because we only round off to two decimal places in the final answer. Compute the ln of 41,123 over 37,600. And you should get 0.089. And as I said earlier, you take all the decimal numbers because we will only round off to two decimal places in the final answer. Now we compute 12 times ln of 1 plus 0.074 divided by 12. You start with ln of quantity 1 plus 0.074 divided by 12. And the answer you multiply by 12. And you should get 0.07377. And you take as many decimal digits as you can from your calculator. Now we divide this decimal number by this decimal number. We have 0.089563. 5252 882. We divide that by 0.073. 77276 703 4809. And you should get 1.2140. It is this decimal number that we will round off to 2 decimal places. To round this up to 2 decimal places, you round up the third digit from the decimal point. And that digit is 1, 2, 3, 4. Since the 4, the number to be rounded up, is less than 5, we simply drop 4 and all the digits to its right. And we do not add 1 to the digit preceding 4, which is 1. Hence, the final answer, time t is equal to 1.21 years. This means that the principal of 37,600 pesos would accumulate to 41,123 pesos at 7 and 2/5% compounded monthly after 1 and 1.21 years. We take the ln of the left hand side, we write ln of 57,900 over 30,700. And we also take the ln of the right hand side, ln of quantity 1 plus this quotient to the power 2t. Take note that the digits, there is still a bar at the top of above the digits 285714, because when you enter this decimal number in your calculator 0.034285714, you should repeat these digits 285714. After 285714, you press again 285714. Now we apply the property of natural logarithm to the right hand side of this equation. And this property says this is the particular property of natural logarithm that we will use for the right hand side. The ln of x to the n equals n times ln of x. What happens here is the exponent n was brought down as coefficient of ln. There, and n now becomes a coefficient. And n is multiplied by ln of x. So if we apply this property of ln, we bring down 2t as coefficient of ln. And the left hand side is the same. the left hand side of the equation, we still have ln of 57,900 over 30,700. Now from this equation, we can solve for t. We must eliminate 2 from the right hand side. So we divide both sides of the equation by 2. And we must also get rid of this ln of quantity of this sum. 1 plus 0.034285,714 divided by 2. We divide both sides by the product of 2 and ln of this sum. We start from the right hand side. We have divided the right hand side by the product of 2 and ln of 1 plus 0.034285714 over 2. And we do the same for the left hand side. We divide this quantity by 2 times ln of this sum. For the right hand side, 2 divided by 2 is 1. So you can cancel out 2 over 2. And ln of this sum divided by the same quantity, ln of this sum is also equal to 1. So you simply cancel out ln of the sum. 1 plus 0.034285714 divided by 2. And what is left at the right hand side is t. T now is equal to ln of 57,900 divided by 30,700 over 2 times ln of 1 plus 0.034285714 divided by 2. The value of t is given by ln of 57,900 divided by 30,700 over 2 times ln of 1 plus 0.034285714 divided by 2. If you have a scientific calculator and you know how to use your calculator, you can compute this quotient directly in your calculator. Or you may do it this way. You start up with the numerator, compute ln of 57,900 divided by 30,700. But you take all the decimal numbers because we will round off to 2 decimal places only in the final answer. We compute ln of 57,000. ln of 57,900 divide by 30,700. $30,700. And you should get 0.6344547. And this decimal number we divide by 2 times ln of quantity 1 plus 0.034 285714 divided by 2. We compute the denominator and we also take all the decimal numbers. We have 2 times ln. ln of 1 plus 0.034 285714, and you press again 285714 because the digits 285714 are repeated without n. Zero 285714 is divided by 2. And you should get 0.03. 0.0339951. Finally, we find this quotient. We divide 0.6344, 0.63445, 472, 998, 579. 634454 729 998 579. We divide by 0.033 339951 5273 714. And you should get 18.66309. And this is the decimal number that we would round off to 2 decimal places to write the final answer to 2 decimal places, and the unit should be in years. To round this up to 2 decimal places, you count the third digit from the decimal point. 1, 2, 3. The number to be rounded up is 3, but 3 is less than 5. So we simply drop 3 and all the digits to its right, and we do not add 1 to the preceding digit 6. Thus, the final answer is 18.66 years. To answer the question in the problem, how long will it take for 30,700 pesos to accumulate to 57,900 pesos at 3 and 3/7% compounded semi-annually? The answer is 18.66 years. For your practice and assignment, please do the following exercises. How long will it take 70,000 pesos to accumulate to the given amount at the given rate? For letter A, 70,000 pesos accumulated to 83,400 at 9.5% compounded quarterly. And you will find the time that it will take 70,000 to accumulate to 83,400 at 9.5% compounded quarterly. For letter B, 70,000 pesos accumulated to 120,800 pesos at 7.5% compounded monthly. For letter C, 70,000 pesos accumulated to 93,100 at 12% compounded semi-annually. Thus, for these three letters A, B, C, for A, B, C, you have the same initial amount or principal of 70,000 pesos. But the accumulated amount is different and the compound interest rate is different for each of the letters A, B, C. For you to be able to check your answer before your submission, I give you the answers in years to 2 decimal places. For letter A, the answer is 1.87 years. For letter B, the answer is 7.30 years. And for letter C, the answer is 2.45 years. And that completes our lesson for today. If you have questions about the lesson today, you ask your questions in the comments below. And don't forget to subscribe to my YouTube channel, Art Calison, the channel of learning and leisure. Or you may ask your friends, classmates, and neighbors and relatives to subscribe to my YouTube channel, Art Calison, so they may learn as well. Thank you for joining me in my class today in Mathematics of Investment.